Here we have been asked to find the zeros of this polynomial function. To find the zeros, we set f of x equal to 0 and then solve for x. In this situation, trying to decide how to solve for x requires us to remember some things that we learned in an earlier chapter. In this example, notice that we have 4 terms. Also notice that they are in descending order on the right-hand side. Earlier, we have solved this kind of problem by factor by grouping. That means that you group the first 2 terms together using parentheses. You always put a plus sign, and then you would group the the last 2 terms with their signs in the second group. From here, notice that an x squared is shared in the first group. So pull out an x squared, and we'd be left with x minus 2. Now the rule of the second group is, so long as this first term is negative, you will always pull a negative sign out. So in this case, I would start this by saying negative, and then the number common would be 9. And then because we pulled a negative out, the signs of the 2 inside numbers are going to change. So this would now be a positive x and then a minus 2. The goal of this is to try to get this factor equal to this factor. If those 2 are not equal, then the likelihood is that something is wrong or that it won't solve by using this particular method. Now once you have those 2 terms equal, you write that value that's equal in the front once, as it is our common factor, and then you multiply by what's left over. I call this my leftovers. And so I would say times x squared minus 9. Now from here, I want to make sure that each of these groups is factored completely. The x minus 2 is factored. The x squared minus 9 is not. That's difference of squares. So I would write it as x plus 3 times x minus 3. At this point, once you have everything completely factored, see if there are any factors that are repeated. In this case, there are not. Notice that each of these factors would have an understood power of 1. That will tell us something about the multiplicity of these zeros. Now, something that was stated earlier was that if you had x minus 2 as a factor, then you knew already what your 0 was. Your 0 for that particular factor would be the opposite. X is equal to 2. In this one, if x plus 3 is a factor, then x equals negative 3 is a 0. On this one, if x minus 3 is a factor, then x equals positive 3 is a 0. Underneath each one of these, I'm going to state their multiplicities. This one has a multiplicity of 1. This one has a multiplicity of 1. And so does this one. Okay, we know that because of the understood powers on each one of these factors. Now for each, since these have odd multiplicity, then the graphs at each one of these zeros would pass right through those x values. Okay, so knowing these multiplicities later on will help us know how to graph this particular problem.